So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on AC generator. So let's begin with the worksheet. So here is the worksheet on AC generator. So the first question is AC generator works on. So AC generators are based on Faraday's laws of electromagnetic induction. We rotate a coil in a magnetic field. Because of that, the flux linked with the coil changes with time. That induces a current which changes with time, which we call as the alternating current or the AC. Next is a question is being given that a AC generator is made up of coil of area A and it is rotated with an angular velocity omega. If the magnetic field is B, initially B is parallel to the area vector, then the first question is find angle between B and N at time t. So initially we know that the angle between magnetic field and area vector is 0. So after time t, let us say angular velocity is omega. So theta will be omega into t. Next is find phi t. So magnetic flux is B dot A. So which will be B into cos theta. Theta here is omega t. So that will be B into cos omega t. Next is find induced EMF. So induced EMF is minus of d phi by dt. So that will be minus d by dt of BA cos omega t. After solving, we have BA differentiation of cos omega t is minus sin omega t into omega. So we have BA omega sin omega t. Next is find peak value of induced EMF. So peak value of sin is 1. So the induced EMF will be having peak value of BA omega. Next is find angular frequency of induced EMF. So that will be also omega. Next question is find time period of induced EMF. So it is 2 pi by omega. Next is find frequency of induced EMF, that is 1 by t, which is omega by 2 pi. Next is if resistance of the coil is R ohm, find instantaneous current. So current is EMF by R, which is B omega sin omega t by R. We take that as I naught. So current is I naught sin omega t, where I naught is B omega by R. Next question is find instantaneous power. So power is V into I. So we just substitute the values and we have B square A square omega square by R into sin square omega t. Next is find average power in one cycle. So we take the average. We know that average of sin square is half. So that will be B square A square omega square by 2R. Next is frequency of power. So frequency of power is it's a sin square terms. So that will be omega by pi. Next is time period of power. It is 1 by frequency, which is pi by omega. Next is angular frequency of power. That will be 2 omega. Next is the question where magnetic flux is given as phi naught sine pi into 10 is to power 2t plus pi by 3. Here it is a small t Weber. The question is find initial magnetic flux. So substitute t is equal to 0. We have phi is equal to phi naught sine pi by 3. Sine pi by 3 is root 3 by 2. So that will be root 3 by 2 into phi naught. Next question is angular frequency of flux. So that will be pi into 10 is to power 2. Next is frequency of flux. So that is omega by 2 pi, which will be 50 hertz. Next is time period of flux, which is 1 by f, which is 1 by 50 second. Next is induced EMF. So that is minus d phi by dt. So minus phi naught into cos of this thing into pi into 10 is to power 2. Next is amplitude of induced EMF. So take cos term as 1. So we have this as the amplitude of induced EMF. Next is angular frequency of induced EMF. So that will be pi into 10 is to power 2. Next is frequency of induced EMF. So it is omega by 2 pi, which is 50 hertz. Next is we need to draw the graph. So graph will be like this. Next is at what time is maximum. So as you can see from over here, is maximum at t is equals to t by 2, which is pi by omega. Thank you.